Good afternoon, everyone, and welcome back from lunch. Thanks to all of you who have shown up, and I know that people are still trickling in, but in the interest of time, we'll get started. I'm CP from Mobi, and our third session is about emerging applications on blockchain in mobility. We have 4 different topics to cover. We'll start off with a talk on technical aspect of blockchain design, its issues, and some of the solutions. Then we will talk about Mobi Grand Challenge, which briefly you had heard in the morning. Then there is a talk on the convergence of new tech, AI, ML, IoT, and blockchain. And that will be followed by a panel discussion. So let me introduce our first speaker, Sid Masih. Sid is a current Mobi fellow. He's an undergrad from UC Berkeley, and formerly he was the head of product. Oh, yes. Yeah, sorry. Oh, congratulations, Sid. And he was the head of product with blockchain at Berkeley. He is very actively involved with Mobi's first standards, which are going to come out soon enough, on vehicle identification. So without further ado, Sid, please join me in welcoming Sid.
All right, so thank you all for having me, especially the organizers. So I think the big takeaway that I really want to get out with the short talk is sort of putting the mental framework of organizing design when it comes to especially automotive applications in blockchain, because there are certain unique constraints. So this is a high-level talk, so feel free to flag me down later for the technical side. I think CP already introduced me, so in the interest of time, why don't we start with framing the problem from an automotive perspective. So we've talked a lot about the challenges of having all this new data and all these new applications that are coming out of it with connected cars and all of these amazing new fields that are coming out, but there's a certain problem, and the fact of that is if we start moving all this data across wireless networks in our cars, we only have limited bandwidth. So when we start to work with especially smart applications in automotive, we have to deal with the fact that we're working with limited bandwidth. We can't always push what we want through. We have lossy connections because, again, we're working with wireless here, and I don't think there's a very big push to put Ethernet cables into all of our cars and sort of put wires on them. So that's another thing that we have to deal with. And additionally, our cars move because they are cars. So that's another technical design challenge that we have to work with. So that's just automotive. Now we can move on to some of the more famous blockchain ones, which are transaction speeds, expensive storage, and liveness and synchrony. And so just to put in the perspective of a current at-scale blockchain solution, so Ethereum and Bitcoin have 14 transactions a second and 7 transactions a second. I'm sorry, I'm jet lagged. I tend to eat words. 7 transactions a second compared to Visa's reported 65,000 transactions a second throughput. So this is a very big difference. So when we work with automotive, that's unacceptable. We have to be able to handle more information moving through our systems. And the other big one is liveness, which is a very fancy word for saying our network needs to be able to do things, do work, basically. So a good blockchain system, especially in automotive, must address these constraints. So I'd like to talk about the 4 main design verticals, which I would argue are scalability, privacy, latency and liveness, as well as cryptoeconomics, which is probably the most important one. So we'll go over all 4. But before we can do that, just to give a quick refresher of the blockchain stack, we have our application layer, which is where users such as you and me would interact with the system. We then have our symbol control mechanism, which is a very scary word for basically saying we don't want people to pretend who they're not. So identity, basically, followed by our consensus, which is how do we get our nodes to agree with each other, our network, which is how do we move data between our nodes, and then our hardware and infrastructure, which is, well, what do we run this whole system on, because eventually everything touches silicon. All right, so let's start off with the fairly uncontroversial topic of the importance of scalability. So as I stated before, it's cited as one of the biggest objections to blockchain technology, and there's actually two aspects which are not really discussed. So we generally talk about throughput, which is we want to be able to handle more transactions moving through our system. But one thing that's not really addressed actually is storage, and this has to do with the fact that in a traditional Bitcoin or Ethereum style system, we constantly have to duplicate data between each of the nodes. And this is often cited as a good thing, right? Because we want to have control over what's on our nodes and we want to be able to verify all of this. But at scale, especially if you're looking at 1 billion connected vehicles, that starts to not work out so well. That starts to become extremely expensive. So there's a couple of solutions that I would like to discuss, as well as how we would like to approach these solutions. So one thing, especially when we're working in a specialized field like automotive or healthcare or whatever, is we want to sort of take the side effects of these solutions and use those to our advantage in that specific field. Now, in our case, in automotive, one of the big things that we do have control over is hardware, which is very unique compared to any other field. So with automotive, we can actually exploit hardware advantages such as Intel's software guard extension, which is their secure enclave, and use that to increase the scalability and power and throughput of our system. Additionally, the other big one I wanted to talk about in throughput scaling is sharding, which is basically we have a big network. I'm not the first person to do that. We want to chop up the network into different distinct parts. And if, for example, if we do this geographically, well, all of a sudden we start to contain many networks, which are significantly faster, but they're still a part of an overarching ecosystem. So now I want to address storage scalability, which I think is very interesting right now. So I want to start off with saying this is not something new. So a long time ago, back in Berkeley, California, actually, there was a system called RAID invented, and people were very excited because it provided the ability, redundancy, such as if my hard drive fails, I can recover that information. So you can see where I'm starting to go with this when it comes to storage, right? We don't have to replicate data everywhere, and they do exist existing solutions such as polynomial encoding, which is really just taking what we did in RAID and then applying it to blockchain. So this starts to make large-scale blockchain systems for automotive a lot more viable, where we aren't running ridiculous costs storing lots of data. So I did list a lot more others there. I encourage you to look them up on your own time, but since we are running behind time, I'd like to now move on to another very uncontroversial topic, the importance of privacy. So especially like over the last year and a half, we've seen a huge resurgent interest in privacy because of famous situations like the Equifax or Google hacks, as well as GDPR in Europe. And especially this poses a daunting challenge in blockchain because, well, blockchain systems are inherently public in some way. For example, with Bitcoin, you can see everyone and you can see every transaction they've ever made. And based off of that, you can start to see user behavior. And that becomes a very tricky issue because at the end of the day, we don't want to force users into a very exposed situation where they have to show much more than what they already have. So what are some ways of looking at this from an automotive perspective? Well, there's two different ways. One is current active research, and the other is solutions that we already have. So I've divided the two up over here. So in terms of protocol privacy, which is how do we apply this directly within blockchain architecture, we have two main areas of interest for automotive, which are zero-knowledge proofs, which is a very buzzwordy thing, but I promise it's much more interesting. And so basically, it's a way of saying, I'm person A, I'm going to pay person B, and I'm going to have this public blockchain system verify that without actually knowing that I paid person B. And the cryptography behind it is extremely complex and well beyond the scope of here, but it is especially, I think, important for automotive moving forward. However, it's very slow right now and it's not completely developed. And it is moving in a direction that is becoming faster and more commercially viable. But again, when we work with solutions, we have to work with technology that we have, not technology that we think we will have. The other big one is secure enclave. So I mentioned this a while back in scalability, is again, we have control over our hardware. And the way secure enclaves work is within the processor and hardware itself, we're able to perform the secret information and then have a blockchain system publicly verify that it happened. So you can see the big benefit over here is we keep the important information private, and everyone knows that we're acting honestly without betraying a lot of personal information. However, these they do have their problems, which is they're very hackable. Everyone knows about Intel's Meltdown and Spectre attacks. So that's another, but however, for automotive, again, because we do control hardware, it's something that we can change out much faster and regulate. The other big thing I wanted to talk about is private chains. So it's a dirty word for many people, but at the same time, when we're working with an automotive solution and the people who have the incentive to cheat each other are much smaller, what we can do is secure that information behind a system and prevent the general public from doing that. And in that sense, we deal with the privacy problem at the onset. So I know privacy was a big issue for some of the people over here, as we heard from previous talks. So there are ways to deal with it, fortunately. So bottom line, we still don't have all the solutions. We're getting there to where we do, but we do have to work with the technology that we have. So now we get to what I really like, but I'm told it's quite boring, is latency and liveness. So the whole idea of we want to reduce the amount of time that it takes for information to move from one person to the other, as well as have the network move forward to be able to do work without stopping. And the main motivating reason behind this and why it's so important is that suppose that I'm in my car and I'm approaching a parking garage and I want to park in a reasonable amount of time. I can't wait for an hour for this blockchain system of identity to prove that it's me. So latency and liveness deal with that situation where we want it to be almost real time. Because again, automotive is real time. Cars move in real time, unless they're in traffic, in which case they don't. But, sorry, my jokes are terrible. So there's multiple ways to deal with this. They are traditionally from classical distributed systems, so big data systems. A lot of this stuff was actually done in the 90s and 80s. So like constant distribution networks that provide a way to broadcast information. But I think the big one that I want to talk about, since this is a semi-technical talk, is fewer validators. If you reduce the amount of people who have to communicate with each other to approve transactions, that by definition makes the network more live. And if we use a family of protocols, which are all the modern ones, such as Tendermint and all, it's called partial Byzantine fault tolerance, it exponentially increases the throughput and liveness. So again, I think the parking gate problem shows that we need networks to be active and available. Now we get to what I would argue is the most important pillar. So crypto economics, what is it? It's not a buzzword, but what it does say is that we want to incentivize people to behave honestly within the system. We want validators to honestly validate transactions that move through them, and we want users to honestly use the system and not exploit parts of it. So I'm sorry, that's the jet lag coming in again. Crypto economics is the entire set of ideas of providing incentives, basically, such as do we need tokens, what do they look like, do we even need them? So now we get to, I think, the most exciting part, which is we get to talk about one of the active projects that we're working on in Mobi, of which we're about to publish pretty soon, although I've been told again to not give dates, so I'm not giving dates. So which is our vehicle identity project. So it's actually, in terms of use cases, very, very simple. And it goes like this. We want a unique ID that identifies a vehicle. It's sort of the digital twin that Chris was talking about a while ago. And we want that number to map to a certificate which has extra information about it, about that vehicle, so usable information. And we want the people to be able to interact with those certificates and numbers in a permissioned way that basically goes like this. I shouldn't be able to view the private information about our prime minister's car. Easy peasy, right? So, And again, this is a really cool project because right now the current system of using VINs, which is that number you see in your dashboard, is almost inherently not digital. It's not really used outside of going to, your dealership, or I need to get service on my car. And we could be doing so much more with that. So the VID project is a way to do that. So a good way of visualizing it is like this. We have our users on top, such as our OEMs, our governments, our owners. They're interacting with this cloud, basically. They don't see the individual nodes and validators. So it's this nice abstraction over there. And then below that, we have our consensus network and infrastructure, where we have our validators and so on. So now let's analyze this use case with our 4 pillars. So I'm actually going to start at the bottom, crypto economics. So who's a validator in the system? What are the incentives to do things? Well, our validators are actually, if you think about it, the set is quite small. We're really looking at people who have a chance to disagree with each other, or who want to disagree with each other. And those people tend to be OEMs, automakers, and governments. Governments always like to disagree with each other. So in that sense, what we've just done is we've reduced the number of validators significantly, allowing us to scale the system up, which is, again, important if you want to work with, 1 billion connected cars. So now I'm going to start off with scalability. Because we just reduced the number of validators, we've increased the throughput massively. And if we use a modern consensus protocol, unlike Bitcoin's proof of work, or Nakamoto consensus, technically, is the term, what we can do is, again, deal with the storage problem directly, and also deal with the throughput problem directly. Now with privacy, because the set of validators is small and contained between certain entities, we can simply use a private network and obscure a lot of the very sensitive information from the general public, because the public will only care about their vehicle, or if they need to do something with somebody else's vehicle, rather than every single vehicle. And this gives us a neat way around some of the current research with ZK snarks, which is not ready yet. Now with latency and liveness, again, we can apply some of these outside protocols and outside technology, and use that again to make this a real-time project. And that, I think, is why a lot of us are so excited about the VID project. Is we have the technology here. We're not waiting on anything new, and we're pretty excited to move forward with it. So we just examined a real project with the 4 pillars of automotive blockchain projects. So if there's any questions, I don't know if there's time. I'm happy to take them now. It was a lot. I know, but people are food coma. 5 minutes? Awesome.
So my question, obviously, I have many, but one on the latency and liveness issues.
Yes.
The whole point of this one question would be, why even bother with synchronicity on the blockchain? Why not have that async as... Hello? Is this better? Yeah. For the blockchain layer, with respect to your latency and liveness problem and solution, right? So one point of view would be, why bother with synchronicity on the blockchain layer when it's only going to be used for a few, let's say, tamper-proof checking, sharing of data, creating certificates, allowing permissioned access. Why not have the normal transaction layer as it happens in real time, and you avoid all those latency issues, liveness issues, having to synchronize across the validated nodes.
So you do bring up a very valid point there, which is we are dealing with a heavily read-only network.
Yeah.
However, when I'm referring to synchrony, I'm actually talking about the actual network itself. So suppose that I create a new car, or suppose that I want to have something read, like my credentials verified. We still have to contact the system, and to do that, it has to process through the system. So when I'm referring to synchrony, I'm referring more so to that, rather than to the async issue, which is we can wait in certain cases for information to propagate. It's not necessary that it propagates right away.
Correct, correct. So my question would obviously come in the next phase of vehicles, which is, level 2, level 3, level 4, level 5 autonomous vehicles, where the actual data issue becomes much more pertinent. The security and the privacy and the real-time nature of data, and obviously the bandwidth is going to be huge. So obviously,
It's still huge right now, right?
It's
I was
huge
trying to
right now.
access Facebook and
Right. But obviously, it's going to be terabytes of
Mm-hmm.
streaming data. So per hour or even per minute,
Mm-hmm.
all your LiDAR data, camera, etc. So obviously, that should not go through the blockchain layer, right?
No. I mean, at the end of the day, we do have to design our applications smartly.
Yes.
We can't just send whatever we want. I can't just, for example, I think like a good analog is when I fly on an airplane, a first class seat does not cost with an economy class ticket. There is a premium for using data, and we simply have to design our applications around that. Yes, right over here. Ooh. Second time.
Yeah, so my question is, when you're comparing about the liveness, 65,000 transactions per second, with this kind of a solution, how close does it come to?
So that's the thing. When we look at transactions a second, that's not everything. So in this case, we're looking at, as you said, it's a heavy read-only network. We're not actively committing information onto it. If you want blockchain to rival Visa, that's just not going to happen. It cannot physically happen with all of the nodes and all. But that's not the point here. The point of a blockchain solution is to have various hostile entities cooperate with each other. And if we design around, for example, read-only solutions where we're not constantly touching or the blockchain, but instead we're just reading off of it, that's something that instead can happen much faster. And that, in that case, is we can have a reduced transactions per second. As to what is acceptable or not, that's something that is use case by use case.
Yeah, for the mobility side, how do you dissipate the risk? That means if it is a read-only network and you're gonna be, OEMs are the major people who are gonna be using that data. So the number of vehicles obviously is more, and the number of the kind of data which is created obviously higher. So that is why I want to know approximately how close will that get?
That's a really tough question. That's a very implementation specific one. So short answer is, I don't know. But the thing is, we can get quite close. In a hypothetical network, we can get extremely close. And again, that depends on how many validators we want to have. Because if you want to speed up to like a Visa level, you simply just have fewer validators, right? But there's no inherent magic bullet that will speed up transactions a second. Yes.
Couple of questions from my end. I'm Syed from Cognizant Connected Products.
I'm sorry, I can't hear you.
I'm Syed from Cognizant Connected Products.
Nice to meet you.
Yeah. So, what is the problem using with WIN? And you are talking about VID. And what is the problem in using WIN? And how are we leveraging onboard diagnostics data from the automotive, designing your use cases in the automotive?
All right. So let's start with VIN. So it's like this. Suppose I can carry around a fat stack of cash, or I can carry around a credit card. So you can see why I would want to carry around a credit card, right? The credit card is digital. I don't have to worry about having dealing with the physical system.
You mean to say that WIN is not digital?
The VIN is not exactly digital, no.
It is digital.
But it is true, but it's not in the sense, when I say digital, it's a static number that you will find on a dashboard or you can look up, true. But it doesn't inherently talk about, it doesn't give the richness of a certificate or something like that, which is more truly digital. And it's also a haphazard system of some countries have a registry, other automakers will not. So there's no standardization across that. So I think the VID project is a big push towards that. So yeah, true, it's not fully physical, but it's not, it could be a lot more is what I'm trying to say. And I'm sorry, what was your second question?
Yeah, leveraging onboard diagnostics data. I think we can connect for the first question. I have some.
Oh no, feel free to, I'd love to talk more about this.
So the second question is how we are leveraging the onboard diagnostics data from the automotive, designing your use cases.
So that's a very implementation specific question. That's not my main area, but I'm happy to forward that to the right people.
Yeah, thank you.
Any others? Done? Really quickly.
One question. What use cases do you see with the VIN?
Or the VID, I think you mean.
Yeah,
So I think one of the big ones is if we can have a digital identity of a vehicle that allows, for example, with rideshare, have a lot more accountability to be able to use the vid to open, again, like parking gates, and many, many others which we don't really know yet. Because again, like with Uber, it was heavily disruptive, right? We all of a sudden now have rideshare. So I think with vid, it will make those systems much more accountable and much more viable.
So enhancing machine-to-machine communication.
Correct. So vid is, so if you're dealing with machine-to-machine, the vid is extremely powerful because it provides a single source of truth.
I have a very quick one.
Yes.
So your vid project sounds very interesting. Where I can
Thank
find
you.
more detail about it?
So that's the thing. We are in the process of releasing it. I've been told to not tell any dates. But talk to me offline and I can put you in contact with somebody who can talk more.
You can join Mobi, get standard.
Or that. Join us.
Thanks.
All right, thank you, everyone.
I'll talk about the background and what we have done so far at Mobi Grand Challenge, and then Tram is going to come over and talk about where we are going from here. So in the morning, Chris mentioned Mobi Grand Challenge, we have loosely modeled it in the lines of DARPA Grand Challenge, 2004 DARPA Grand Challenge. DARPA, as you know, is an agency of the United States Defense Department, and it's involved in working on the emerging technologies for military use. In 2004, the challenge that was posed to the teams was to navigate 150 miles autonomously in Mojave Desert in California. So the first attempt was a failure. The best team could go only 5% of the course. After only 18 months, in the second one, there were 5 teams which completed the course, and 22 out of 23 teams that participated actually had better performance than the best team, which was there 18 months back. And that sparked a whole bunch of interest in autonomous vehicles, and billions of dollars poured in from the industry and the venture capital community. So we feel that our grand challenge also can have a similar effect in bringing in the interest and the investments in blockchain and related technologies to make or to take mobility to the next level, and which will make mobility greener, safer, more convenient, and affordable, which is essentially the mission of Mobi. It's a 3-year project, and every year it is done twice. So the first one was launched in October 2018, and it ran till January, and we ended that with an award ceremony in a colloquium like this one, which was hosted at BMW headquarters in Munich. And the second one we will talk about when Tram comes here. Sorry, it's going the other way. So we believe that in 3 years, we should have the technology, or we hope to have the technology, which will help form ad hoc networks where cars can talk to each other, or car to car, or car to infrastructure, to share data, and that will help improving the mobility or taking it to the next level. So even though it may sound very futuristic, we actually do see that happening in the nature. See, if you see a flock of birds or a school of fish, they are moving together in a very coordinated manner, but there is no central command. The bird is communicating with its nearest or the immediate neighbor, and probably a consensus is occurring, and the signal gets transmitted, and the entire group of birds, they increase their range of vision or the range of perception exponentially. Like Praful, I think, mentioned earlier in his talks, in this blockchain type of network, you are neither at the center, but you are at the center type of mechanism. So that's how the schools of fish or birds, flock of birds, they are moving. And it's already happening in the nature. Can we have similar type of technology which the connected cars can use? So the Mobi Grand Challenge was hosted entirely online. So it's unlike any other typical hackathons that you see where over the weekend of 48 hours, marathon programming with pizzas and Coke. It was not like that. It was run entirely online, and it ran for, as I said, 3 to 4 months. There were 3 requirements from the teams. They had to submit a write-up, they had to submit a video of their product actually working, and they had to submit the code. Another difference with the regular hackathon was that the code didn't have to be written during that just 3 or 4 month period. I mean, they could have submitted a project which they had done earlier, but as long as it related to blockchain and related technologies with mobility. We had very good participation from across the world. We had 23 teams participating from 15 different countries, and that was done without any marketing, without much marketing from Mobi. These are some of the typical projects that we saw, and you will see most of these items were also discussed in the morning. Payments was a very common topic or common project that we saw. Like when I talk about payments, it's like the payment from a car to another car or payment from a car to infrastructure. So an example of payment from a car to car, say, for example, if I'm stuck in a traffic and I have an important meeting to go to, or I have a critical patient in my car and I need to rush to the hospital, can I make a payment to the car in front of me or the car in front of that car and buy my route so that I can go faster? So one of the issues with that, besides many other technology issues, is that the cost of transaction in today's world, which was again discussed earlier, is very high. So if we can use blockchain to reduce that cost, such microtransactions could be possible. A car to infrastructure is quite obvious, like paying for the tolls or paying for gas or petrol when you buy that. So those type of projects were pretty popular. Then rideshare and car share. Again, this was a topic which was discussed this morning. There were several, and this essentially solves or addresses the issue of very low asset utilization, which is there in cars. And we heard several numbers being thrown around, anywhere from 90% to 95% is not used. So essentially the car is used for only 5%. You take the car to your office, it sits there in the garage, maybe you take it out for a few other meetings going around, then come back home, again it's sitting in the garage. So there were several projects working on rideshare, car share, which can increase the asset utilization, thereby also helping in reducing the congestion as well as pollution. Vehicle charging, with everyone focusing on EVs, that was another major topic. And Praful put it in a very interesting way, that it's a scarce resource as well as it is underutilized. It's a very contradictory thing. How do you resolve that? And identity. That's another fundamental building block, which from Mobi also we have taken up that as the first working group standards. And because for any machine-to-machine communication, you have to trust the other party, the counterparty. Because in our today's physical economy, there is a trust. When I'm paying or sending money, there is a bank in between. But when you are paying directly, you need to trust that other party. So there were several projects working on that identity. The judging criteria, there were 4 judging criteria: creativity, which means that how original the idea was or is. Technical, how well the code was designed and written. Impact means how many lives can it impact, and the feasibility of that solution. We had a very distinguished panel of judges, and it was represented from the OEMs, technology companies, venture capital firms, and nonprofits. Several of our members stepped up and provided prizes. We had several cash prizes as well as tokens. There were a couple of interesting prizes. One was given by Accenture, which was they invited the winning team to one of their global innovation hubs. As a matter of fact, the winner of the first phase is currently at Accenture Singapore Innovation Hub, working with Accenture and their partners. Amazon, AWS, gave out deep racers, which are essentially miniature version of autonomous vehicles, where you can program for machine learning and improve the algorithms for AVs. So I'll briefly talk about the winners that we had. The first position went to Chorus Mobility. Their solution helped form ad hoc networks, again, vehicle to vehicle and the vehicle to infrastructure, the example that I was giving earlier, so that the car owner can actually buy the route, purchase the route and its rights of way to go faster or whatever they want to do. The second position was won by Oken Innovations. They partnered with a company called Brisas, which is one of the leading toll booth operator in Europe, for making payments for tolls using tokens on blockchain. We had a tie for the third position, which New Cipher and NICS Labs. I heard one of the questions earlier about this onboard diagnostic data. So they worked on a system whereby the car owner can share, say, for example, the onboard diagnostic data with some other parties, for example, the insurance company. And this was another theme which was discussed earlier, like blockchain can help this data sharing between parties which don't trust each other while keeping the security and privacy in place. The other company or the other team that won was from a university in Germany, Fraunhofer Blockchain Lab, and they built a solution which was platooning. So it essentially gave some of the benefits of autonomous vehicles without actually releasing the full control of the vehicle. All of these projects, actually all 3 projects, their videos are uploaded on our site. So I'll highly encourage you to go to our website, www.dlt.mobi, and you can see all these projects there. So now I'll ask Advesh to run the video for our winning team. It's a very short 1.5 minutes video. It'll show you what they built on blockchain. I think the sound is not coming.
We're Course Mobility, a research and development startup working on blockchain solutions for transportation. We were one of the first companies to design and publish an open software hardware architecture for the blockchain-based vehicular ad hoc networks. Our goal is to create a feasible system that allows for autonomous vehicles to become independent economic actors, drastically improving traffic safety and lowering the cost of mobility. To participate in the Mobi Grand Challenge, we've partnered with our friends at Decentralized Tech, the San Francisco startup behind the decentralized platform that helps companies to monetize robots as a service. For our demo project, we've utilized advanced developments in the robot operating system as well as EVM-based infrastructure for cyber-physical systems. Nevertheless, our blockchain-agnostic architecture allows to quickly switch the blockchain type, depending on the current needs. In 2008, Seattle-based engineer William Beatty, in a series of experiments, established a so-called traffic waves theory. The thesis of that theory was that by knowing how traffic waves are formed, drivers could sometimes reduce their effect by increasing the distance to the car immediately ahead of them. This would lead to braking less often and ultimately decrease the accumulation of vehicles and traffic around them. But to motivate drivers for the described behavior, we as humans need to unlearn everything we were taught about standing in lines. The system we introduce will allow to financially incentivize both human and autonomous driving vehicles to maintain such behavior by getting paid for the road space and yielding to the other cars. We hope that this system will evolve to become a part of our daily traffic infrastructure.
Okay. So in the first phase, we saw a lot of projects which had machine-to-machine communication, and it was all focused on connected vehicles and on the machines. In the second phase, and Tram is going to talk about that, we want to shift the focus to the human element of mobility. A quick introduction. Before co-founding Mobi, Tram was an art conservator and educator for 20 years at Getty Museum in LA, leading specialized projects, conferences, and workshops in the US, Europe, and Middle East. Please join me in welcoming Tram.
Thank you, CP. As he mentioned, I'm not a technologist. Before I became an art conservator, I was a chemist and a biochemist. And last year, I quit my job when Chris and I launched Mobi, almost a little bit over a year ago. It was May 2nd of last year. So quickly, the reason why we launched the Mobi Grand Challenge, as you can see today, that we are nowhere near the autonomous car that everybody talk about and get excited. You know, the kind that I can sit in the back seat going home from work sipping a glass of wine. So what's happening is, for the last 15 years, the smartest scientists has been working on this, and we are nowhere in sight of a true level 5 autonomy. And according to a RAND Corp study, 1 trillion miles will be needed of self-driving data for autonomous car to be accurate and safe. So, and Waymo, a Google startup on autonomous car, clock about 25,000 miles a day, and based on the simple calculation, it would take 110,000 years to get to that 1 trillion miles. So that won't be during my lifetime. And as we've been seeing, what's happening is that cars are becoming smarter, and they're communicating with each other and infrastructure, and to participate in a machine economy. And the hardest problem with the machine economy is, how do you identify the identity of that machine? According to this study that you see here, 52% of the internet is from bots. And of that 52%, 56% is actually malicious. So the bad guys are winning. And blockchain can be used to verify identity and bring trust to a machine economy. As CP mentioned, for phase 2 of the Mobi Grand Challenge, we are trying to bring back the human factor. After all, machine communicating with machine is only a mean to an end. Is to make our lives happy, much happier and easier. And the idea for the Mobi Grand Challenge came when I was listening to a BBC podcast on a Green City program in Bologna, Italy. And the city government of Bologna give out really tiny incentives to try to get their citizen to choose green option, green commute option. And the gamification aspect of the program really intrigued me. It worked. People actually go out of their way to do green commute just to get a few points. And it takes a lot, like 2 weeks to a month to be able to get enough points to get an ice cream or a glass of beer, but they do it. So, and the cities around the world are evolving rapidly. I'm a city girl. I was born in Saigon, a city of 15 million people. And according to the UN, 50% of the world lives in urban area. And by 2050, that number is going to become 70%. That's an increase of 2 billion people moving into the cities. So building additional infrastructure for peak demand, like concert traffic or rush hour. Los Angeles has the Olympic in 2028. That's really expensive and not practical. So what's practical right now is that we need to come up with better ways to manage the existing infrastructures that we have. So to meet this challenge, cities around the world are experimenting with a lot of incentive programs to make the cities smarter and greener. And as a result, cities are spending a lot of resources to collect a massive amount of data, hoping that data will help the city become smarter. And as I mentioned, I come from a nonprofit sector, and I think one of the hardest questions for nonprofit sector to answer is, how do you measure success? It's not as easy as counting how many cars were sold. And to be able to answer that question, you need to have trusted data, data transparency, and data management. And blockchain can bring you closer to get all those three trifecta, in my opinion. So Mobi envisions a tokenized Citopia ecosystem where city governments work with employers, university, schools, to create incentives for the citizen to pick the correct choice, the choices that the city wants them to pick. And in the end, to create a greener and smarter city. And all this can be done on a phone app with a blockchain backbone. Like Tim mentioned earlier today, it doesn't matter that things are being done on blockchain. That can be in the background. The foreground is what you see and what you use, and if it's easy, then people will use it. And congestion pricing or parking incentives or usage-based payment for infrastructure can be built into this incentive program to make the city smarter and greener. And the data can be used to calculate anything the city is interested in. For example, the carbon footprint reduction, or how many percentage of citizens are using green commute based on this incentive program. And if I was a business, I would be really highly interested in knowing if I donate $20 into this incentive program, how much do I get back out of it? For example, if I was walking to work for 2 weeks out of the month, and I have enough point to collect a burrito at a restaurant in Los Angeles, if I go to that restaurant, I probably will bring along my friends with me and spend more money. So if businesses know this for a fact, that their $20 actually get them back $50, they would be more inclined to donate more money into the system. And then the tokens that they gain back, they can either donate it back into the system or exchange it with the city for incentives that the city has predetermined. In Citopia, the gamification and tokenization fund competition will encourage the citizen to pick socially responsible behavior. And we just launched Citopia this morning. We've been working really hard to invite judges from around the world to come to witness possible blockchain solutions for solving urban issues, urban problems. And we have judges from the United Nations, we have judges from World Economic Forum, city government of Singapore, city government of Milan, and city government here in India. And we have had prizes donated so far from Amazon, Web Services, R3, BitGreen, and Ocean Protocol. So we're actively looking for more prizes. So if you know of organizations or individuals that's interested in donating, please contact me. And like last time, we have a video created for this challenge. And this is not a technical video. It's meant to be inspiring. And also, we didn't have a lot of money to spend, so we use our own voices. Imagine a smart city that uses technology to guarantee us safe and hassle-free transportation.
No more congestion, no more choking exhaust fumes, no more car accidents due to careless or drunk driving.
A human mobility solution that is efficient and sustainable, that protects our environment and enhances our quality of life. To realize this vision, the Mobi Grand Challenge is introducing its second phase, Citopia.
According to the United Nations, 50% of the world currently lives in high-density urban areas. That number is likely to increase to 70% by 2050, an increase of 2 billion people in the next 30 years. Building additional infrastructure to accommodate this increase is incredibly expensive and not sustainable. Sustainable urbanization and our quality of life increasingly depends on the successful management of existing infrastructure. In an urbanizing world, mobility is a major driver of climate change, contributing as much as 60% of a city's emissions. Transportation is now the largest source of carbon emissions in many countries.
Cities around the world are experimenting with numerous incentive programs to create smarter and greener cities with happier citizens. The problem is, we don't know if these programs are effective or not. To measure success, we need much more data transparency, reliability, and management. Zootopia envisions a tokenized ecosystem where city government works with employers, schools, universities, and local businesses to create incentives for citizens to change behavior and to make our cities safer, greener, and more livable.
Tokens earned by participating in the ecosystem can be exchanged for goods and services offered by local businesses and government agencies, or donated to a charity. All will be done with mobile interface built on a blockchain backbone. Blockchain, distributed ledger, and related technologies enable trust, traceability, and transparency in data management while preserving privacy.
Congestion and pollution pricing can easily be incorporated into the Zootopia token reward system. Targeted incentives can help cities manage peak demand sustainably without building additional infrastructure.
Tokens can help cities incentivize and track green mobility behavior, monitor the growth of sustainable commuting, and the reduction of the city's pollution and carbon footprint.
They can also keep track of how local businesses benefit from increased commerce. In Zootopia, gamification, tokenization, and fun competitions create powerful incentives for socially responsible behavior. The possibilities are endless.
Developers entering the Mobi Grand Challenge Phase 2 will be expected to demonstrate how blockchains and distributed consensus protocols can help solve urban problems with incentives in a tokenized ecosystem. Solutions include, but are not limited to, congestion pricing, carbon footprint management, parking, usage-based payment for infrastructure, multimodal transit, data exchange, and micropayments.
Building on Phase 1 of the Mobi Grand Challenge, Phase 2, Zootopia, explores new solutions for human mobility to create smarter and greener cities with happier citizens. So, do we have time for questions? Yeah, okay. Any questions about the challenge? We just launched it this morning. So we have a DevPost site. You can go to it and register. I encourage, if you know of developers who are interested in doing this, please register. We have 3 months. The projects have to be turned in by September, and then the judging happens at the end of September. And in November, we have a function in Los Angeles where the top 10 teams will be invited, and we'll announce the winners there. Any questions?
Hi, so how do you, this is Sumit Dhanuka this side, just a quick question, how do you ensure that the winning projects in some way go out and get commercialized in some part of the world?
It will get what, I'm sorry?
So how do you ensure that the winning projects after they come out of the challenge, go out and get commercialized in some part of the world? Because at the end of the day, yes, a challenge should lead to an outcome, yes, and a tangible outcome in the interest of human life. So how do you make sure about that?
Yes, so the reason why we invited so many city governments around the world is because people are still seeing blockchain as a possible solution to many of the challenges that they face in the city, but they don't know really how applicable it is. Since we have so many of these government entities, I'm hoping that by the end of the challenge, they can see the applications and then open up sandboxes in their cities so that these winners of the challenge can come and start doing application for the next round. It's a 3 years challenge, and we're doing this every 6 months, so this is just the second phase of the first year. Next year, we'll have phase 3, and hopefully we'll be able to pair up cities with the winners and start testing out some of these things. Any other questions? Yes.
One more question. So again, if you look at India, as in there are quite a bit of uniqueness in the way in which the transportation ecosystem operates. So when it comes to a challenge like this, how does the challenge ensure that the nuances of the local market? So for example, a bunch of Indian entrepreneurs who go in and apply for a challenge may their solution may be restrictive to the Indian market need, right? May not be relevant to the globe. So how does the consideration flow, because it may not align with the American or the European markets? So how does
Yes.
it operate in terms of unification of the problem statement to a global use case?
Yes. So it depends on the city, and I think every city has its own challenges and the different solution that can be applicable to that city. And it's not just traffic pattern, for example. It's also culturally too. How do you solve a problem? Culturally, it can be very different. And so I agree with you. I think right now we're still at an early stage. I want cities to see all these applicable solutions. And then the next phase, I would like for us to start conversation. And during this whole time, we are envisioning that cities would get on the phone also with developers who have questions to answer questions. So it's not going to be working in silo and not knowing what the cities want and what the cities need. And then on top of that, we are in the process of making available data from different cities around the world. So the city of Los Angeles data will be available for developers to plug into. City of Singapore also has data that they are offering through Ocean Protocol. And we're talking with Milan for the data of their city. And Pune also is decided to also put up some of the data for us. And another entity we in the process of talking with, and we hope that will become possible, is the European Space Agency also. And they have satellite data. And so slowly we're bringing data in, and the developers get to see what is available, and then hopefully talk with the city to see what challenges they're facing and solving problems. Like for example, crossing the street is not easy as crossing the street in Los Angeles as here, for example. So things like that, yes, definitely. I think we need to get on the phone regularly to have cities talk, to let the developers know what they're looking for. Because developer, you're right, can come up with something that's only good for one location, but not for all the cities around the world. Yeah. Any other? Yes.
Hi, I'm Debupam from RPG Smart Infra. My question is that apart from the city, there are a lot of other stakeholders when I'm trying to solve a blockchain problem, like we are getting the local businesses in, plus a lot of other something like public transport is involved. A lot of different government agencies are involved. So what kind of support are we getting from the city over here, apart from the data? Like, will they kind of help us in liaising with these agencies as well, liaise with the local industries, local commerce as well?
That's what we're hoping also will happen. Right now, cities are still wanting to sit there and observe some of the things that are coming up. But I'm hoping that the next round, more city agency will come in. Because one of the things that we've noticed when we talk to a lot of foundations that do funding for city programs is what they're noticing is cities can have 10 programs and they all working in silo and they don't communicate with each other that well. And at the end of the day, it's hard to connect data from different cities' programs. And we're hoping that Citopia can help also bridging the data between different entities within the cities. I hope that answered your question. Yeah. So. Are we out of time? Yeah, sorry, we're out of time. So if you have any more questions, please talk with me during the break.
So as Tram mentioned, that we launched Citopia this morning at this colloquium, and I'm hoping that we will see a lot more teams from India participate, and hopefully a few of them on the winners podium in November in LA. Our next speaker is Mr. Dilip Krishnaswamy. I would like to invite Dilip to the podium. Dilip is the VP New Technology Initiatives and Head of Blockchain Platform Engineering at Reliance Jio Infocom. He has a PhD in Electrical Engineering from University of Urbana-Champaign. He has previously worked at IBM Research, Qualcomm, Intel, and taught at UC Davis. He has over 60 patents, 70+ publications with 3 best papers. His research interests include distributed information processing, distributed function virtualization, distributed resource management, blockchain technology, 5G architecture, and others. Please welcome Dilip Krishnaswamy.
So I want to take a slightly, I want to bring you back to IoT, AI, and blockchain and stuff, but I want to give you a little bit of perspective on where infrastructure is going, and that will give you some ideas about what you might, how you might want to create solutions anticipating such infrastructure. And they are all happening together. So, you know, there's a convergence of 5G, IoT, AI, blockchain, and so on. And how do we all bring it together? You know, it should be fun going forward. So we'll give it a try. Thank you for the introduction, CP. So if you look at networks, I mean, traditionally, you know, you have an application and it just goes through routers and goes to some server in Google on the internet. And everything is just packets moving. But and with cloud computing, we pushed all the work to the cloud, but going forward, we will see actually compute and storage move into the network. I mean, and it's already happening, and it's already happened in many places as we start deploying edge computing use cases and so on. So you can start thinking about, say, N3B down here. What's this? Yeah. So there's some users moving around this, and there's an edge cell around here, and you know, sorry. How do you move this? Where do I point this?
Yeah. Yes.
This one?
Yeah.
Oh.
It moves forward.
Oh. This one? Okay, no. How do I go back? Okay. This one? Going the opposite direction. So there'd be users down here, and too sensitive. I think I'll just use the.
I gave up and used that.
Okay, sorry. So there will be users down here, you know, there will be people moving around here, and you might have a local blockchain network there, collecting information, right? Maybe somebody walked somebody across the street, and you know, you want to give that incentive to that user, but there's a camera there that's capturing that for the initiative that you're proposing and recording it right there, right? So you don't have to wait for information to go all the way. You could probably collect the credits for that local community at that local edge compute infrastructure and so on. And so something else may be happening out there and so on. And then you would not only be just communicating, but also be interacting in the infrastructure. Some of the use cases that we talk about at the edge are like augmented reality, you know, or virtual reality and so on, or video streaming. You know, instead of going all the way to the cloud and there's an excessive latency to go back and forth, and you just want some help about, hey, where is the nearest Thai restaurant where I am and so on. And you know, the response will be much quicker, and that cell that's there has to search a much smaller database, right, to actually respond to you. And in fact, it doesn't even need to know your GPS, because it knows where you are because you're connected to it. So there are a lot of advantages to actually doing some edge processing and so on. So, but in the process of doing that, and as we think about all the use cases that we are thinking about, there are a lot of transactions that are happening. It need not be financial. It can be information about people, and that could be useful to society, and you would be collecting them. And so depending on where you want to process and how delay tolerant information is, you could have a hierarchy of blockchain networks and intelligent processing anywhere, all over this, in the network, all the way up to the cloud. So think about that. Think about hierarchical and distributed AI and blockchain going forward, and how you can have fun with it. So, when you try to deploy these kinds of things, you might have a small data center at Noida and in Gurgaon. It may have a lower latency to access stuff, but it may have a low capacity and high energy cost in and around Delhi. But there may be a larger data center in Delhi. It would have a slightly higher latency serving the users down there. Again, a high energy cost, but higher capacity. And maybe somewhere near the Ganges with solar and hydro and wind and all, we could have a really low energy cost data center. Higher latency, but if things are delay tolerant, you could push some workload there. So going forward, everything is going to be very fluid. What functions execute where can be completely dependent upon capacity and the needs of the flow and things like that. In which case, you don't know, dynamically you might figure out where you want to actually execute the service and where the data is going to be produced. And so you might have blockchains everywhere, right? And they would all talk to each other and so on. So, and smart processing as well. And you want to figure out where to keep what, and there's something called, so that's called distributed function virtualization, and then there's distributed software-defined networking that controls where these things move around. So this is where infrastructure is going. It's very fluid. Previously, it used to be like hardware boxes talking to each other, but with like, for example, 4G protocols went through many releases. 5G protocols are going through many variations and so on. Instead of having a hardware box and just for the next version you want to take that hardware box and put a new one in, you could just switch the virtual machine or switch the container, and it's so much more easier to manage with software. But having done that, now you have edge compute and storage, which you can use for applications and services and blockchains and AI and everything. So it's going to be fun with infrastructure changing like this. And this is some work that we did with mobility management, where if hierarchical processing is very useful, because let's say you want to manage a whole bunch of users in an entire city, and you try to figure out what to do with them all at one central location. And sometimes you have to solve an optimization problem, and the dimensionality of the problem is pretty large. But if you break it up and solve at the edge, as the users are moving, you solve around here and solve around here and so on, they are executing concurrently. So you're actually processing this much faster. A smaller dimensional problem at the edge is being solved concurrently. And at the same time, maybe you have to consolidate information across the boundaries, and that you would do at a higher level, but that would be a much smaller complexity problem. So then a lot of information actually would benefit from hierarchical and distributed processing as well, not just for fun as well. So, and 5G has a whole bunch of things happening with high bandwidth, ultra reliable, low latency, like for firefighters and police to talk to each other, or for robotic surgery to happen remotely and so on, or massive machine type communications. And then you could communicate with millimeter waves, or sub-6 gigahertz is happening sooner. That's the frequency at which they will communicate. And then the core networks are getting virtualized, and there's mobile and multi-access edge computing, slicing, analytics optimization. So a lot of fun happening in the 5G space, and throw in blockchain as well. So, and it's actually really beneficial to society at large, because when you get into edge computing and services, you can essentially have a local community, even if they don't have backhaul connectivity to the rest of the world. They could be talking to each other. You could have a local WhatsApp or a local Twitter. The farmers could be talking to each other. School children could be talking to each other in a village. And you can have applications such as banking, healthcare, microfinancing, and so on, emergency, IoT services, and so on. So, and you could you could collect a lot of content and just place it at the edge and serve that community. So, there's a lot of benefit in trying to look at these kinds of architectures and see how you can serve such communities. And then we were talking about different communities having different kinds of needs. And so that local blockchain service that is there may be different for that community, because we want to serve that particular community, what its needs are. And you guys have seen all this, but blockchain systems will promote, bring trustedness, immutability, consensus, provenance, smart contracts. But the cool thing is, it's not just about data, it's also about the smart contracts. So you also thinking about the logic, and the logic can actually be smart. It's not just a programmable software. But if you have something programmed that is intelligent, you might, based on the inputs that are coming through IoT, you could be having some automated intelligence in the software that goes and controls something else in the system, and drives it. So, and then you record what happened, so that everything is very autonomous. The system is executing smartly in the smart contract, controlling stuff. Humans may not be involved if not needed, and you could still be recording such information on blockchain. So. And so with smart communities and communities, different kinds of applications, they can all benefit from this kind of infrastructure. I want to share a couple of jokes. So I'm not sure if you've seen this. Our Prime Minister had said, if you just want, blockchain has been hurt a little bit because of the cryptocurrency and crypto tokens kind of work that was going on, which was getting bad pub. But truly, there are benefits to actually using blockchain technology beyond this. There's also this Dilip cartoon, if you've seen this. But I just wanted you to take a look at it. And it's true, right? There's so many blockchain consultants these days, and but it's sort of going through a bit of a disillusionment phase, and then it'll come back. So and the right things will survive, and it's really great what you're doing. I mean, you're touching people, right? You're making blockchain connect with people, and I think that with your project with Mobi, and I think it's a really good thing. So often we just talk about enterprises and blockchain for companies to automate their stuff and all of that. But truly, if you look at use cases where we can actually help people, then that would be a great thing. And so we have all of these use cases. You've seen all of this, IoT or real estate or supply chain. Or in telecom, actually, in India, you have your DND, do not disturb, or the UCC, unsolicited customer communications, has actually been regulated by a regulatory authority. So it's actually on blockchain right now, and it's an interoperator network that is being launched. So actually, Telecom is the first launch on blockchain actually in India from the regulatory side. So. And you can also benefit people, refugees or migrant laborers and so on. And you can use it for different applications, whether it's UCC or mobile number portability or trying to track data sharing on an interoperator network. This is a paper that was written. It's about mobile number portability, but if you see it, it's more about, hey, I have this system, but I need to move it to a neutrally managed entity. And then how do I design the state machine transitions to actually make that system work on blockchain? So it might be a use, you might find it interesting to see if you have a use case, you could just go through that flow of logic that we had in the paper. I won't go to smart contracts, but this kind of typical logic that may be there. But as we go forward, you will have 5G, IoT, AI, and blockchain all coming together. 5G can, will be allocating resources dynamically in this programmable infrastructure. IoT systems are active, monitoring people, and things and so on. Smart contracts are active data and executing intelligent software, and then blockchain platforms are recording, and maybe, you can have listeners on a blockchain, so you can take quick actions and with PubSub and all of that. So it can be fun. So And some of the applications can be emergency healthcare, energy management, automotive, smart agriculture, tracking people and pets and retail. For migrant laborers, for example, and a lot of the time we talk about fintech and money on blockchain, but you can help people. If there are migrant laborers, for example, their families lose touch with them and they go from employer to employer. And potentially if you have a blockchain that records what they have worked on, maybe that helps them get a next job, based on the work that they did. And every time they get a paycheck, maybe a message can be sent to the mom saying, hey, your son got a paycheck here. And so the mom knows, okay, he's alive, So, there can be a lot of good things that we can do. So we can have provenance on blockchain for people to help people, right? And can have distributed smart energy transportation management. These energy vehicles can be automatically, detect a need for EV charging, locate the nearest station, and even drive it. Microgrids can be interacting with the core grids, and we can have energy distribution, and you can manage transportation and traffic as well. So, and then emergency healthcare. This can be like a really true use case with IoT, AI, and blockchain. The IoT sensors are monitoring this patient. The patient and decides, hey, needs to go to the hospital, and but the patient is being transferred to the nearest hospital, but that hospital may not be the one that has the patient's records. And as the patient is going to this nearest hospital, the data can be transferred, and that could be based on a consent that's given live, or maybe it could be a pre-authorized consent. In an emergency situation, allow this data transfer, so it automatically goes to the hospital, the patient arrives, and it's treated well, and maybe the insurance is also processed along the way. So, you can have a lot of cool things that way. So, there are things that we can do to share information. In this case, we're sharing information across hospitals. And you could also try to maintain privacy by trying to keep data off-chain, but recording the event on-chain. And I want to close by talking about this project that's going on at the Indian Institute of Science. And I think this is optimal for ocean. Is the team here? So what Professor Bharadwaj is doing at IISc is trying to bring India together and different smart cities to come together to submit the data into a common system, so that different sources of data can work together and to provide integrated services and the multimodal services that we were talking about and so on. And so potentially there could be, this information could be blockchain, privacy managed, and all of that stuff. So I think it's ideal for Ocean probably to kind of step in on the blockchain front on this. But if you are building any solutions for smart cities for India, I would encourage you to join in this. And right now, there are definitions of APIs for different types of traffic that could come in and all of that that's going on. So please do participate in this project. It's IUDX. So, and that's all I had, I think. Oh, okay. And this is the future, we think. So automated, intelligent, quantum resistant. You could just use a SHA-3 algorithm, so you can be attacked by a quantum computer. But you really don't want to go live, have a live transaction with the quantum computer. Maybe too much latency, but you just want to be protected from it and with your data. But you would have this data processing storage in a distributed manner with smart agents, with smart contracts interacting across these distributed cloud edge networks. But at the end of the day, we should try to provide useful services to people. And that's where we should go. So thank you. Yeah. Yeah.
So just going back to your SDN slide. So would the main purpose of a distributed SDN be? Thank you. Would the main purpose of a distributed SDN be to coordinate between autonomous systems, or what would be the main use case for such a thing? Because SDNs are inherently centralized in a sense.
Yeah. So the original SDN, the way it developed was to kind of centralize, But now there's a new redefinition or emergence of SDN from a distributed manner, because the infrastructure is distributed. And so you got to control applications and services and functions here. You also want to control here. But the latency tolerances of functions that are executing may be higher up in the cloud. We have much more latency sensitive down at the edge. So the algorithms and that would execute to manage the functions at the edge would be different from what manages the stuff in the cloud. And you want the control plane to have a minimal latency to this edge, so that if something is managing stuff in the cloud, it may be too far away to control here. So then that naturally separates the control as well.
That IUDX project.
Yeah.
The IUDX project, that seems very interesting. Maybe that's the Indian Ocean.
Yeah.
Now, my question is that, are these 100 smart cities going to use that, or how else are they going to
That's
share
the plan. Yeah, sorry, that's the plan, and the ministry, the government is involved in supporting IAC, and so they're bringing the community together. And yeah, they're hopeful that this is a platform that can be used in all the smart cities.
So, sir, you have seen, like, you have presented a lot of new technologies about NFV and blockchain and all that. But end of the day, how do you see the business use cases for telecom operator in next 5 years? So we have talked a lot about technology, but I think I would also like to hear about some business use cases where we can utilize it, especially for a telecom operator.
So I think the business use cases are driven by people. If you make a difference to people, they automatically make a difference from a business perspective. So I think that should be the primary goal. And so, and you know, we talk about AI and blockchain, and you know, it's not necessary that we have to use every technology in every use case. But you know, for example, this healthcare use case might benefit from this kind of solution. Maybe if you're just doing content management and it's solely managed by one provider, then maybe you don't need a blockchain for it, but you need a distributed infrastructure for it. You might need some machine learning to learn you know, what this community likes, and then give them content ahead of time. But at the same time, that may not need blockchain. So you would want to, depending on the use cases, you want to mix and match and see what flavor of the solution is actually useful for that particular community. And I think, you know, the smart cities kind of stuff, and every smart city may have its own needs. The solutions that emerge for every smart city can be different. And that's where I think we should start with and make a difference. Thank you.
Next, we have a panel on smart cities and mobility and blockchain. It'll be moderated by Mr. Manojit Bose. Manojit, in fact, is one of the judges for our Citopia. Manojit, he is the Chief Knowledge Officer for Pune Smart City, responsible for driving all the ICT-led initiatives like the Integrated Command and Control Center, Smart Parking, and others. He also leads the Pune Ideation Factory Foundation, PIFF, a subsidiary of Pune Smart City SPV. He has been involved with this 100 Smart Cities mission from the very beginning. Prior to joining Pune Smart City, he was involved with several other state and central government agencies. He is currently involved with setting the standards for different smart city projects, and has earlier worked in several senior and executive roles at NASCOM, Cognizant, and TCS in India, US, and Japan. I would like to welcome Manojit. Please, if you come and introduce your panel. will introduce the panel.
I would request my co-panelists to join me, Mr. Jayant Kohale, Business Head Smart Cities from RPG and KEC Group, Mr. Parna Ghosh, Group CIO, Minda Industries, Mr. Anindya Mallick, Partner Deloitte, and Mr. Punit Shukla from the World Economic Forum. So, CP, thanks for the introduction and thanks for having me here. It's a matter of privilege to be presenting in this, such a wonderful session here. So, the way we would go about this panel discussion is I would try to set the context for from a smart city standpoint on what urban mobility is, what are the immediate challenges that we are encountering on a regular basis, and throw open the panel discussion to the esteemed panelists who have arrived here. And towards the end, we will have a few rounds of questions from the audience, and then take it ahead from there, right? So. For the uninitiated, the smart cities journey kind of started sometimes in 2014, 2015. And it was primarily a bottoms-up kind of an initiative which the government of India had undertaken, unlike several other missions. Now, when the cities were preparing the smart city proposals to be considered funding by the government, there was an extensive amount of citizen consultation which was carried out. And most, if not all the cities, they spoke about mobility as a challenge. And therefore, when the smart cities, the 100 smart cities as and when they got selected, when they prepared their plans, one of the key components of their plan was to solve the urban mobility problem, right? But then, what people realize sooner than later is urban mobility is just two words here, right? Urban and mobility. But within this, there are so many of those issues and challenges. And urban mobility, though it sounds very simple, is a multi-headed monster, for want of a better word. There are multiple elements to it, and there is no one way of solving the urban mobility challenge, right? So when we undertook this journey in, from a Pune smart city standpoint, there were a lot of thoughts which came to the table, right? And rightly or wrongly, technology seemed to be the panacea for all the urban mobility challenges which people were facing. It was felt that you bring in some technology and it's like a magic wand and it pretty much solves everything. We went deeper and deeper into the subject. And our realization has been quite different from what we started off with. So technology certainly has a role to play. But then we also need to identify which part of urban mobility are we trying to solve. If it is the traffic congestion problem, the commute time, the network traffic speed, if those are the areas we are trying to talk about, technology certainly has a role to play. But then, urban mobility is also about last mile connectivity. It's about ride sharing. It's about, intelligent transport management system. It's about passenger information system. It's about e-mobility, e-buses, e-vehicles, and whatnot. So we started working piece by piece. Because if the problem size is too huge, you better start nibbling at it and start solving some of those elements. So we developed an approach, a multi-pronged approach to solve a multi-faceted problem, and got going on that. But while pursuing this particular line of action, we also realized, say for example, if you want to solve the problem on network travel speed on traffic congestion, which is at the top of the mind of pretty much all the cities in the country. Technology alone will only help you so much. And then, along with technology, what you also need to do is probably look at redesigning of the junctions, right? And for doing the redesigning of the junctions and for implementing technology interventions, like say something like an adaptive traffic management system or synchronization of signals, right? You would also require a thorough traffic study to be done, which of course we are undertaking with the help of a drone. What we also realized is, you may have a junction properly redesigned, you may have the best of technology interventions in the world, but then what do you do if the number of cars on the road, they keep on increasing year on year? So when we speak to people, the best of breed OEMs coming from different parts of the world, they are not willing to provide or assure you of a KPI which is more than that of a year. So what they're saying is, we can give you a network travel speed improvement of say something like a 10 to 15% for the first year. But then if the vehicular density keeps on increasing year on year, their technology may not be able to solve it, right? So that's one set of issues. And then we realize that even if we were to assume that technology can really solve the problems with IoT, with AI, with blockchain and whatnot, and with junction redesign and all those elements which come into from a typical urban planning standpoint, if enforcement is not there, even both of these done will not work, right? So that's the reality when we talk of urban mobility from a city standpoint. These are some of the experiences which we have gained over the last couple of years. And every city in the country is trying to solve the problem. Approaches will be different. And the methodology, the technology interventions, the overall macro planning is going to be different. Now, with these words, I would now invite Anindya Mallick, who is a partner with Deloitte. He is focusing on the smart cities, to share his views on urban mobility from a smart city standpoint. Anindya.
Thank you, Manojit. Hi, everyone. So I'll build on what Manojit just spoke about. So from a smart city point of view, if you see what is a smart city is all about improving the quality of life of the citizen, and also ensuring that the city is an engine of economic growth. So that means that there has to be the city has to kind of build an economy around it, which will have various participants, both the citizens as well as people coming from outside. And that is where mobility plays a very big part or a significant part in the smart city development. So from a citizen point of view, if we see that in terms of mobility, what is the expectation? An expectation is that a citizen should be able to, or a visitor to the city should be able to reach from point A to point B for to conduct any business that they want in various through various modes of transportation that may be an option for them to use. And of course, there are various price points to it. So if you see what other cities have done, like if you take the city of London, which has Transport for London app, there if a citizen gives that I want to go from point A to point B, it will give all sorts of options for that citizen. So whether if the person has its own personal car, it will only it will give what is the less congested route, so that you reach that that place within a particular the least possible time. If you want to use public transportation, then what are the various modes that are available? Like the public transportation main would be possibly the metro rail system, or if some city has a bus rapid transit system, or the buses. And to reach the stations, which is the first mile connectivity, and from the station wherever you want to go, that's the last mile what are the various other options which could be a local taxi or a ride share like Uber or something like that. And that will also enable you to book the service and pay for it if you are done. So that is where technology comes into use. Now, if you're a person using your own vehicle, say to go from point A to point B, you will want to use the least congested route, and that could happen through synchronizing traffic light, as was discussed, through the automated traffic control system. So that there actually you are using artificial intelligence, cognitive technology, where through various mechanisms, the traffic flow is being monitored at each of the junctions, and the information is flowing from one signal to the other, so that the traffic signal times are being coordinated. So that is about the going part. But if you look at congestion, which is a real problem in most of the cities, the congestion studies have shown that nearly 30% of your congestion is for private vehicles looking for parking spots. So that if, again, using technology and that has been built into the intelligent traffic management system in the smart city, one is the infrastructure part, that is you designate the car parks, which could be street parking or even multi-level car parks at various points of the city. And based on the destination you are going, you can book your parking space for a particular period of time, and for that booking, of course, you can make an online payment. So you're assured that wherever you're going to get parking space, so you'll be off the road. So there is it in fact brings in a lot of benefit to the citizen. Similarly, when we're looking at use of multimodal transportation, where we are encouraging citizens to actually leave their private vehicles and go for utilize public transportation. So we have to see the simplicity and the ease of actually using that. So that again, when we are planning our journey, we should be able to use a single payment option. So that comes through the mobility payment mechanism that can be built in. So you will not pay at each and every point. It's a single payment, which possibly the citizen is just getting messages that this has your account has been debited and so using, and it's all using technology. Now, even where governments have used various mechanisms for reducing congestion, like if you take the case of London's congestion charging, which is now getting replicated in cities like New York, there we see that even though this system came maybe 10 years back, the use of technology was there from the very beginning, so that as a citizen who's driving into the congestion zone, you are not inconvenienced. So first of all, you don't have to stop at any place. It is the cameras which are recognizing the vehicle which is going, seeing whether that's in the database, whether the congestion charge has been paid and which plan they are on. And once you're inside, then of course the various facilities are there in terms of where you can park and where you can use other modes of transport. As part of doing such a large-scale implementation of a new idea like congestion charges, which we may be looking at Indian cities also, there are three things that you need to do. One is, first, there has to be a policy which the city government needs to enact, which will allow the city to go for this congestion charging, and also tell the citizen what they need to do. Like they need to register their vehicle, they need to have upfront prepayment of congestion charges, so that and there are various pricing. If you prepay, you have a reduced pricing. If you post-pay, there is a increased pricing for that. So all that mechanism needs to be the cameras with the number plate readers and all, which that will be there. And also importantly is the infrastructure. For those who do not want to say pay the congestion charges, infrastructure in terms of periphery of the city, you have parking lots and all. So person can get down and he can use the the various other options which are there within that zone. So these are various initiatives which have gone into planning mobility for cities and which uses a lot of technology, which I think my co-panelists will talk about.
Thanks, Anindya. So very clearly, urban mobility, smart cities, there can be multiple use cases. Problem definition is clearly one of the most important ways to start taking a shot at solving some of these problems. And as Anindya spoke about, there are a lot of technology interventions which are possible. I would now request Parna to throw light on potential use cases of IoT, AI, robotic process automation, and blockchain, even though it's fairly nascent. But how could these technologies individually and all put together make a transformation from an urban mobility standpoint at a city level?
Thanks, Manojit. Hello. Good afternoon. As you know, I belong from the Hello. I belong from the IT fraternity. I believe most of you who are sitting here are definitely from the other background, from the user side of community. So it becomes very difficult, to explain the complex IT scenarios to users in a very useful manner. So let me try my level best for that. First, I'll give a perspective is the Indian economy is moving from a sense of ownership to a sense of service. So everything is moving to a service. If you see the food business, if you see the transport business, if you see the housing business, why the housing sector is not doing well? Because people are going for, rentals, more of rentals. So they don't want to own houses. And same thing happens in every sector. So that is one big move which is happening in the Indian economy. Second thing is, from a blockchain standpoint, some few figures I will quote. 2017-18, the market was having around $350 billion. And it is expected that by 2025, the market is going to be around $10.5 billion, as per the McKinsey reports, which was released last year. And this will be contributing around 10% of the GDP in the year of 2025. So this is as per the expectations of the analysts. So moving forward in terms of blockchain and the use case for mobility for smart cities, it's a very interesting subject. As you know, the market now is getting disrupted very heavily. Autonomous cars, connected cars, electrification, and shared mobility. These all four, monsters are actually hitting the market. I was just talking with Mr. Banerjee few hours back that the market is going through a huge disruption and the complete automobile market is going through a patch right now. And good news is that government is also again reinstated, which will again try to bring a lot of reforms expectedly. But if you see in next March, BS6 is going to be launched. Going forward, electrification, government is putting a lot of focus, and I believe the next panel will also talk about that. So looking forward, the disruptions on top of disruptions, which are actually creating a lot of confusions with the consumers. So I'll give my example. I was waiting to buy a car for last 1 year, and then I was seeing the BS6 is going to come next year, and then finally electric is going to come, when it is going to come, what will be the cost, what is the assurance, what is the infrastructure, and all these questions were hovering around. And finally I had to buy a car which is a simple petrol version. So the point is, the disruptions are really creating a lot of confusion with the consumer mind. Coming back to blockchain, I think we have august speakers who knows about the subject of smart city very well. What I believe is blockchain is basically going to disrupt the entire ecosystem of transactions. Say for an example, we have the SAPs and the Oracles of the world, which traditionally does the transactions in terms of logistics, supply chain, finance, human resource management, or all other areas of IT, transactions. So what blockchain is going to do in future, although the use cases are very limited to some extent as far as the Indian market is concerned, SBIs and ICICI banks have already embarked on the journey of blockchain for last 2 years. But the use case in manufacturing and especially for the mobility sector is going to come. and we are waiting for startups to do some kind of investments and come up in the right foray to participate in this technology innovation. I believe the e-waste management, the energy management, what right now Anindya was talking about, the mobility, smart connectivity between the traffic signals, your education, smart health, all these areas are going to be finally converge into a technology called blockchain. Sounds very optimistic, but it is going to happen. So currently, if you see in IT jargons, we make applications, we have cloud infrastructure, we manage servers, we manage data centers, we manage users, we manage so much of complex environment. This entire environment is going to be disrupted by blockchain sooner or later. It is a matter of time, and I believe the ecosystem which we operate right now is example. We have customers, we have enterprise, then we have suppliers, we have government, we have transporters, insurance providers, regulators, banks. So many people are operating in an ecosystem. This entire ecosystem is possible to be put in a blockchain kind of an environment, and things will move very seamlessly and easily. Digital identity is one of the things which is a very important thing. Currently, as you know, Aadhaar has been rolled out, I think around 4 or 5 years back, and maybe it rolled out earlier, but last 4 or 5 years it became very popular, and the digital transfer of payments and other things are happening through Aadhaar. Identity verification is happening through Aadhaar. This entire Aadhaar system, they are also planning to move to a blockchain kind of environment in next 4 to 5 years time. So this is one of the examples. Digital payment is another example. And then I told about your connected system. Like we see a lot of YouTube videos which shows about a car is powering a house or a house is powering a car, and all this kind of power management and energy management happens, which actually is going to happen through this blockchain kind of an environment, which will give you the feasibility of resource management. Resource is going to be scarce in next couple of decades. And the optimum resource utilization and management will be a very important thing for smart cities, where resource will be a really scarce thing. Example, water, energy, and all other resources which we need to have for our daily use. So I think this is a huge opportunity for us. It's a nascent stage right now for blockchain, and going forward, I think a lot of innovations are going to happen. ERPs will sit on top of blockchains. Banking transactions will sit on top of blockchains. Your utility service providers, the consumption models will sit on top of blockchain, and each will talk with the other services, and we will be consuming the microservices as a citizen to government kind of an environment, which will give a lot of opportunity and benefit to the IT companies as well.
Thanks, Parna. So very clearly, disruption is there for a reality. I mean, and blockchain would certainly only probably accelerate the whole disruption, which is happening all around us. More specifically in the realm of urban mobility, he spoke about the BS standards and a whole bunch of other things, right? So at the end of the day, blockchain, IoT, AI, these are all the new age technologies which we are talking about, and the potential for these technologies to disrupt the urban mobility space, and at the end of the day, provide solutions to very, very chronic problems from an urban mobility standpoint, which the cities have been facing for years now, right? I would now request Punit to share his views and the views of the World Economic Forum on the fourth industrial revolution. I mean, if you look at the fourth industrial revolution, it's pretty much about all these things which we are talking about. Over to you, Punit.
Thank you, Mr. Bose. Thank you for such a great context to set the tone. I'll just talk a bit about what the World Economic Forum and its Center for Fourth Industrial Revolution is working on. So Center for Fourth Industrial Revolution is a network of 4 centers right now based out of San Francisco, China, Japan, and India. An India Center was launched last year, inaugurated by the Prime Minister. Across all these centers, what we are trying to do is to understand the overall landscape of evolution of frontier technologies. Basically, we have chosen 9 such technology areas, which we think are going to shape global technology progress, as well as its adoption and impact on society as well as economy. AI is one of them, blockchain is one of them, use of drones in tomorrow's airspace, precision medicine, smart cities, and data governance are major areas which we think are most important technology progress is happening across the world today. And the idea across all these centers is actually to understand and help countries, governments, international organizations develop a standard for technology governance based on evidence. And based on evidence, by evidence we mean we actually go out and engage with governments and industry to actually implement pilot projects on these specific ideas and specific technology areas. And out of all our centers, we have actually launched a number of pilot projects. So we actually did conduct an entire pilot on precision medicine being delivered by drones in Rwanda. And a very successful pilot helped us understand how do you actually create a real-time risk-based system of governing drone flights. And the Rwandan government actually launched their regulation on drones using that pilot and understanding and using impact assessment of the entire pilot. Out of the India Center, we have specifically chosen 3 technology portfolio areas, AI and machine learning, blockchain, and use of drones to actually understand and see how we can actually engage with the government as well as industry to do some of these pilots. We are already in talks with, so our partners are Niti Aayog, Government of India. We have state governments, Government of Maharashtra is one of our partners to actually engaged in use of drones to for irrigation and building a data utility platform for agriculture. So just a bit of context towards that, and in the urban mobility space, we are also working with some smart cities. We will also plan to work with Mr. Bose here, and we are already in discussions with Chennai Smart City and Smart Cities Mission at the central level to actually see how do you bring an idea of data shared and data governance in a multi-stakeholder setup. And that's where the current panel also comes into being, that urban mobility is a space where government or public service providers will not be the only ones playing that space. I think it's very important to understand and realize that in this age of smart cities, it can't just be the city corporation or the smart city SPV delivering the services. It will be an extremely interlinked ecosystem where government as well as private service providers also work together to deliver services to citizens. And just looking in hindsight, infrastructure was one area where we thought public-private partnership had the greatest strength. And now I think just operations and delivery of services is also another area where PPP is going to play a huge role now. And that is where engagement of industry as well as government is extremely important. And coming to the topic of blockchain and urban mobility, I think 2 specific developments which in my mind are going to completely change the game. One is definitely IoT coupled with AI, more specifically edge computing, where you are able to actually do processing at the edge on the device. And then the next development in blockchain, which would be, in my opinion, interledger communication. And I think if that gets standardized, for example, all the enterprises are going to have their own blockchain. Not every use case is actually amenable to blockchain solution. I think centralized use cases work equally fine in many of these use cases. And I think once you develop a common standard for communication between a decentralized use case and normal IT legacy systems, and once you have developed that communication architecture, because a lot of normal digital normal IT legacy systems work equally fine. Supply chain, inventory management system of companies have been working on centralized architecture of inventory as well as transactions, and they will work equally fine. We don't need to think that every blockchain use case has to replace and remove the centralized IT legacy system. So I think once we develop that standard of communicating between decentralized use cases and centralized architectures, I think that is going to completely revolutionize the game. And a lot of platforms are actually working towards that. Interledger communication is a huge area of research now. There are several platforms and blockchain fabrics, probably Corda or Hyperledger have come out with several new forms of actually doing interledger communication as well. And I think that is going to be a key game changer. And second would definitely be once you kind of move away from public blockchains, you also gain a lot of throughput efficiency as well, throughput gain as well, and speed of transactions. So I think that is definitely also going to completely change the way we look at blockchains not being a bottleneck, but actually being able to make sure that the entire supply chain or the ledger is completely transparent. Transactions happen via smart contracts, and there the overall idea of interledger communication and standardization will definitely play a huge role.
Thanks, Punit. Coming to you, Jayant, I mean, we have been for the last maybe 15, 20, 25 minutes talking about the various new age technologies, the fourth industrial revolution, and how we can kind of go about solving the urban mobility challenges from a smart city standpoint by leveraging this. Now, you are one of the leading system integrators / master system integrators in the country from a smart city standpoint. And you have also been involved in implementation of some of these technologies, more specifically maybe the intelligent transport management system or the adaptive traffic management system. So what are your views on the usage of these technologies from a smart city standpoint?
Yeah, thanks, Manojit. So just a quick word of introduction. I'm part of RPG Smart Infra. It's a business unit of KEC International. We are part of a RPG group. And as Manojit mentioned, we are the master system integrator. What does master system integrator means is the single agency which deals with city and try to provide complete turnkey solution to the city's ecosystem. So in a way, we are kind of hands and feet which work on in the city ecosystem to increase the digital index or to provide the digital infrastructure to the cities. So we as a organization are quite intensely connected with the smart city ecosystem. We are working on few of the cities, and just a quick word on that, as we all know, the program was launched in 2015 and 4 years have gone past. And a lot of cities, almost 60 odd cities, and have done a lot of transformational work. So, and then as being a structured program, a lot of consultants, global agencies, technology partners, integrators like us get involved, and we try to provide the solution. So Anindya, who's sitting next to me, companies like Deloitte will build a concept, a DPR, we will come and implement that solution. So Manojit was asking how it is evolving in India. So I can name quite a few cities where they have done excellent work in this. Pune being the leading name there. Cities like Ludhiana, Chandigarh, Aurangabad, Warangal, all these cities are taking huge strides in building this digital infrastructure. I'm sure this must be quite the surprise news to all of us, but yes, cities are putting a lot of investment in building their digital index. First, the building blocks is based, first comes the communication network, building the passive and active infrastructure. On that comes the edge-level devices, starting with providing the public safety means by putting cameras, but they don't stop there. Then going forward is that video analytics, AI, face all kind of video analytics, whatever is available in global environment are part of our Indian ecosystem. Pune has it, Mumbai has it, Bhopal has it, and other cities are also aspiring to build that kind of solution. So going forward in the area of mobility, now, right now, it's in the evolving stage. So as the panelists also mentioned, there are two pillars of smart city. Of course, better quality of life and sustainability. So in that, to build that better quality of life, we all face the challenges of traffic every day, where the solutions like adaptive traffic or intelligent traffic is being used. This is getting implemented in a phased manner because this is technology is very intense. It takes some time to, and then a lot of pilots have to be done so that we can implement and we should implement the right solution. So just an example for Pune, city of Pune, they did that exercise, they collected the baseline data because the challenge for us as a city, we don't have data. So first thing, how much time it takes from going from, let's say, Yeravada to Pune airport. So we don't have data. So like 9 o'clock in the morning, 9 o'clock in the evening, afternoon. So that data pointers, first is that phase. Then based on data, if I use, then the challenge is the density. Like the kind of vehicle population which has increased on the city is immense. It has multiplied 10x. So will the only technology will help, or we need to also improve the physical infrastructure? So cities pounding on this challenges how to do that, but they are taking strides. So in my limited view, I sense that a lot of action is happening. And of course, the new technology of blockchain, where we are all discussing, I think out of these 4 modules, where it is the infrastructure, platform, accelerator, and application, cities are well conversant with the infra part of it. So they are working with a lot of cloud providers. So in fact, most of the cities have got cloud as a solution provider. There are guidelines defined by various states or how to deal with them. So that part is well taken care of. I think platform and the application or the use cases, this is the area where we all need to work together and find solutions to that. Thank you.
So Jayant, thanks so much. I mean, very clearly it's moving towards an API economy, as we would like to call it, right? Now, very, very quickly, Anindya, 2 quick points. Where do you see the urban mobility from a smart city heading?
I think as we've heard a panelist from urban mobility point of view in smart city, I think for most cities that has been taken as the priority because as I said, mobility is a very important point if you want to improve the citizens' quality of life. So all the investments are not only being made in infrastructure, but on top of that, it is in the automation part, and that's where the stock technologies like blockchain and all are becoming really important because it is because as communication technology cost goes down, we are getting the benefit of leapfrogging actually and being in the right place at the right time.
Thanks, Parna. Your point of views, please.
Yeah, I think the major concern for the implementation of technology, one is the physical systems, second is the application complexity, and third is the government regulations and the plans. I think these 3 has to merge with each other, and I believe the advent of this 5G as a technology which is going to come up in next couple of years as expected. This is going to solve the real challenges of the connectivity and the communication. That is the main challenge as of date today. And then the point which Jayant has mentioned, the applications use cases, I think these are just a matter of time. I think we are just waiting for a couple of years or maybe another 3 years. The blockchain technology is really going to disrupt. And one point I just want to add is, I forgot to add in the previous discussion, is IoT and artificial intelligence with machine learning on top of blockchain. Is these 3 technologies are going to really change our lives, the way we are thinking or speaking, and analytics are going to be the key provider of information for the service providers, so that the services can be personalized, customized, and provided at the doorstep, which currently is a big challenge as of now.
Thanks, Parna. I mean, disruption is the order of the day. Punit, your point of view. 2 points quickly.
So I think 2 most important concerns would definitely, and then concerns as well as way forward for us to progress on the smart city urban mobility front is to be able to figure out the right way of public-private sector engagement. And I think that would be key to any progress which we make. And the second most important point would definitely be, as Parna also made, is the overall government regulation and work an overarching framework under which how do you do all these things. A data protection framework, as well as also making sure that technology governance is evidence, is rooted in evidence, is extremely important for us to institute, and under which all these consortiums, public-private cooperation can definitely take place.
Yeah, thanks, Punit. So, Jayant, to you now, public-private participation, regulatory framework needs improvement. Your quick 2 points on the way ahead.
Yeah, just very quickly, one is the, I won't take more than two sentences. One is ecosystem play. We all need to collaborate here. And going forward, as this opportunity is huge, maybe the regulation will also help us to take it forward. Thank you.
Thanks, Jayant, Anindya, Parna, and Punit. I don't think we have really any time left to take any questions, unless CP allows us to take one or two.
I think we are out of time. Maybe at the networking, we'll take a 5-minute break now.
Sure.
We're running short of time. Yeah. And maybe you can have the Q&A. It goes off that. Yeah, sure.
Thanks so much for providing us this opportunity. Thanks.
Yeah. These are for. Okay. So, Jayant, Manojit, can you give out the mementos to your panelists?
Start from here.
Hey, finally. Nice meeting you.
Let me use this time to quickly introduce myself.
I wanted to, nice meeting you. From RPG, my dad worked for his life.
Oh, really?
RPG.
Oh, fantastic.
CSC. Nice meeting you.
Yeah,
I'll contact you.
Yeah.
Hey, you should. Yes, I'll.